Hello, my name is Alyssa Morel, and my project is over the optimization of histological analysis of 3D meniscal fibrochondrocyte cultures and attempting to validate that by using transforming growth factor beta 3. The meniscus plays a major role in knee joint function, and the inner region of the meniscus is avascular, so when it's injured or deteriorates, it cannot repair itself and the knee can often develop osteoarthritis. Osteoarthritis affects hundreds of millions of people each year globally, yet there is currently no method for meniscal fibrocartilage regeneration. That is why we have taken the approach of using spheroid histology as a tool to help further our knowledge on meniscal fibrochondrocytes, or MFCs. MFCs were cultured using a hanging drop method, which allows them to become a 3D spheroid. Fixed spheroids can then be embedded in agar gelatin and then surrounded by paraffin wax. The purpose of this is to allow cross-linking between the agar gelatin and the spheroids and give the block structural integrity so they can be sectioned without the spheroids falling out. A microtome can then be used to section the blocks for future staining. The stains we chose for this study were hematoxylin and eosin, safranin O, and immunohistochemistry, which highlight our desired proteins. When culturing the spheroids, we added increasing concentrations of transforming growth factor beta 3, which has been shown in previous studies to improve avascular meniscal tears and show intensive staining for collagen 1, collagen 2, and glycosaminoglycan. These are the proteins we analyzed to prove our method of spheroid histology works. Because there is no standard method for spheroid histology, we had to go through a period of optimization. During this period of optimization, we tried multiple methods from previous studies with tissue histology, but ultimately we found flaws when applying those methods to spheroids. The final optimized method we found to work the best involved staining the fixed spheroids with eosin, which allowed us to see them in future steps, and then we embedded each group of spheroids in a 1:1 ratio of agar to gelatin. Next, the hydrogel embedded spheroids would go through a standard dehydration and paraffin embedding process and were sectioned at 4 micrometers. This allows the sections to be thin enough for us to see the morphology and composition of the spheroids after staining while still being thick enough to not fall apart. After comparing the images and diameters of each group from the dosing study, we've come to the conclusion that our results do not fully mimic what previous studies have shown for TGF-beta 3. So further analysis and future testing is needed. But what we do know is that our method of embedding and sectioning is efficient and reproducible and can be used for future studies involving spheroids, such as the one we're doing in our lab, which is a concentration gradient microchip study. Thank you so much for your time, and I hope you enjoyed my presentation.